Hello everyone, myself Hena Shah, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to begin a new topic named Application of Integration, right? So let us start with the first topic, that is length of plane curves. Okay, so let us study the length of arc in Cartesian form. So the length of arc of the curve y is equals to f of x between x is equals to a and x is equals to b is given by s is equals to integration from a to b square root of 1 plus dy by dx whole square dx, right? So this is the formula to find length of arc in Cartesian form. Next, let us study the length of arc in parametric form. So the length of the arc of the curve between the points t is equals to t1 and t is equals to t2 is given by s is equals to integration from t1 to t2 square root of dx by dt whole square plus dy by dt whole square into dt. So this is the formula to find length of arc in parametric form, right? Now let us study the length of arc in polar form. So the length of arc of the curve r is equals to f of theta between the points theta is equals to theta 1 and theta is equals to theta 2 is given by s is equals to integration from theta 1 to theta 2 square root of r square plus dr by d theta whole square d theta, right? So this is the formula to find length of arc in polar form. Okay, so next let us study one example to find the length of the arc of the curve y is equals to log sec x from x is equals to 0 to x is equals to pi by 3. So here the curve is in the form of Cartesian form, right? So we'll apply the formula to find the length of arc in Cartesian form, right? So let us start with the solution. So you are given y is equals to log sec x, right? So firstly we will find dy by dx. So the derivative will be 1 upon sec x and derivative of sec x will be sec x into tan x. So this sec x will get cancelled out and the answer of dy by dx will be what? Tan x, right? Now for the required arc, x varies from 0 to pi by 3, right? This is given in the question. Now let us write the formula to find the length of arc, that is given by s is equals to integration 0 to pi by 3 because our limits are 0 to pi by 3 square root of 1 plus dy by dx whole square dx, right? Now put the value of dy by dx, that is tan x. So what we will get? Integration 0 to pi by 3 square root of 1 plus tan square x dx. But this will be simplified as what? Sec x. And the integration of sec x will be what? Log sec x plus tan x. And your limits are 0 to pi by 3. Okay. So now let us put the limits. Firstly put x is equals to pi by 3. So what you will get? Log sec pi by 3, right? Plus tan pi by 3. Now put x as 0. So log sec 0 plus tan 0, right? Now we know the values of each term. So sec pi by 3 is what? 2 and tan pi by 3 is what? Root 3. And all this term will go to 0, right? Because log 1 is equals to what? 0. So the final answer of the length of arc is what? Log 2 plus root 3, right? So now let us study the next topic, that is area of a surface of solid of revolution, right? So the area of the surface of a solid of revolution in Cartesian form. So the area of the surface generated by revolving the arc of the curve y is equals to f of x about x-axis is given by s is equals to integration a to b 2 pi y square root of 1 plus dy by dx whole square dx, right? So this is the formula of the area of a surface generated by revolving the arc y is equals to f of x about x axis, right? So next, the area of the surface generated by revolving the arc of the curve x is equals to f of y about y axis is given by s is equals to integration from c to d 2 pi x square root of 1 plus dx by dy whole square dy, right? So this is the formula to find the surface area generated by a revolving the arc of the curve x is equals to f of y about y axis, right? So both these formulas are area of a surface of solid of revolution in Cartesian form, right? So now let us study the area of surface of a solid of revolution in parametric form, right? So when the equation of the curve is given in the parametric form, right? X is equals to f1 of t, y is equals to f2 of t, where t1 less or equals to t less or equals to t2. That is the limits of t is varying from t1 to t2. Then the area of the surface of a solid of revolution about x-axis is given by s is equals to integration from t1 to t2 2 pi y square root of dx by dt whole square plus dy by dt whole square into dt, right? Now similarly, if you want to find the area of the surface of solid of revolution about y-axis, then the only change will be here what will come 2 pi x. Okay, other all things will remain as it is, right? Now let us study the area of the surface of solid of revolution in polar form, right? So for the curve r is equals to f of theta bounded between the radii vectors theta is equals to theta 1 and theta is equals to theta 2, right? The area of the surface of solid of revolution about the initial line theta is equals to 0 is given by s is equals to integration from theta 1 to theta 2 2 pi r sine theta into square root of r square plus dr by d theta whole square d theta, right? So this is the formula to find the area of the surface of solid of revolution in the polar form. Okay. So next let us study one example based on this. So we have to find the area of the surface of revolution generated by revolving the curve x is equals to y cube from y is equals to 0 to y is equals to 2 about y axis. So our given curve is in the Cartesian form, right? So let us start with the solution. So here x is equals to y cube is given, right? Therefore dx upon dy will be what? 3y square, right? Now let us draw the curve x is equal to y cube. So this is the curve x is equals to y cube. Now we are given two lines, y is equals to 0, that is your x-axis, right? And the next is y is equals to 2, this is your this line, right? So the point of intersection of this line y is equals to 2 and the curve x is equals to y cube is what? 8, 2. How we have found out this? Just put y is equals to 2 in this, right? So if you put y is equals to 2, you will get x is equals to what? 8. So the point of intersection is 8, 2, right? Now the area of the surface is generated by revolving the region about y-axis, right? So we are revolving this curve about y-axis. For the regions shown here, y varies from what? 0 to 2, right? So the limits of y are varying from what? 0 to 2. Okay. So now let us find the surface area which is given by s is equals to integration 0 to 2 because the limits of y are what? 0 to 2. 2 pi x square root of 1 plus dx upon dy whole square dy, right? Now let us put the value of dx upon dy and this x. It is y cube and this is what? 3y square, right? So now let us simplify this. So what we will get? Take this 2 pi outside. So 2 pi integration 0 to 2. Here it will become 1 plus 9y raised to 4 whole raised to 1 upon 2, right? Now in order to form the derivative of this term, right, we have multiplied and divided by 36. Okay. So here what we have done, we have just formed the derivative of this term at this place. Now we use our formula, that is integration of f of y whole raised to n into f dash of y dy will be equals to what? F of y whole raised to n plus 1 upon n plus 1. So here the derivative of this term is over here. So our answer will be what? This will be get cancelled out. So we will get pi upon 18 times. Just increase the power of this term. So we will get 1 plus 9y raised to 4 whole raised to 3 by 2 upon 3 by 2, and your limits are 0 to 2. Now first put 2 in place of y. So you will get what? 145 raised to 3 by 2. Now put 0 in place of y. So you will get what? 1. Right? So the final answer of the surface area is, pi upon 27, 145, root 145 minus 1. Okay? So I hope you have understood throughout the session. Thank you for watching.